In this example, we will make a cat part from scratch using techniques we will learn in other modules taught in this course. We will start by left-clicking on the plus sign in the 3D Start screen. Remember that when you create a 3D part, you're going to make molecules. Now let's left-click on 3D Part from the selection shown. We are now in the part design environment. CATIA is a sketch-based design system. All parts start out by first creating a parent sketch. We'll start the sketch by left-clicking on the YZ plane, and then left-click on the sketch icon. This creates a sketch on that plane. We are now in the 2D sketch workspace. Note the engineering graph paper background that appears when we're in it. Let's start our sketch geometry by drawing a rectangle. Left-click on the rectangle icon, and then left-click at the point 1.5, 3. And finally left-click at the point -1.5, 1. Note that CATIA has auto-constrained all lines as horizontal or vertical for our convenience. To exit the sketch workspace, we left-click on Exit App to return to the 3D workspace. We are now ready to create a 3D solid from this 2D sketch. Note that the sketch is highlighted or selected. That means CATIA will use this geometry in the next command if it is possible. So let's create a pad from our sketch by left-clicking on the pad icon. This dialog box shown controls all the parameters of this pad. We will discuss this in greater depth in later modules. For now, let's change the height by left-clicking in the text box and typing in 0.5 and then left-clicking on the OK button. Our solid is now 2 by 3 by 0.5. Double-clicking on any object in CATIA will edit it, so let's change the height. Double-click on the 3D solid shown. We get the dialog box back. We're now free to change anything we like. Left-click on the text box, type in 0.75, and then click the OK button. As you can see, the pad now reflects the new height we just gave it. We can also edit the pad from the specification tree or spec tree. To do this, we must first open up the spec tree by left-clicking on the plus sign, and then double-clicking on pad 1 in the spec tree to edit the pad. Again, we left-click on the text box, type in 1.0, and click the OK button. Let's now edit the proportions of the parent sketch. Double-click on Sketch 1 in the spec tree to edit it. We're now back in the sketch workspace. Let's change the 2 by 3 rectangle to a 1 by 6 rectangle by moving a corner point. To do this, we perform a left hold on the corner point, slide it to the point 4.5, 2, and then let go of the left mouse button. We then exit Sketcher by left-clicking on the Exit App icon. The box is morphed to resemble its parent sketch. To change this shape to resemble a wedge, we need to do an edit to the parent sketch. Double-click on Sketch 1. To make one of the vertical lines angular, we need to remove one of the vertical constraints. To do this, right-click on the V constraint. This brings up the contextual menu. Left-click in the Delete section. With the vertical constraint removed, we can drag one of the corner points towards the center and make it angular. Left hold on the corner point and drag it to the point -2, 3, and then release the left mouse button. Left-click on the Exit app to see the result in the 3D workspace. Our solid is now wedge-shaped. Let's manually put the vertical constraint back by double-clicking on Sketch 1 and right-clicking on the canted line. Note that a constraint toolbar appears, giving us a selection of applicable constraints to apply to this line. To apply a constraint to the highlighted line, left-click on the vertical constraint. The line is now vertical. If we'd like to replace all this geometry with something completely different, we can select it using a trap box. To do this, left hold in the upper left corner, drag to the lower right corner, and let go. All geometry within this trap box is selected. To delete it, right-click on Align, then left-click on the Delete option. All geometry is deleted. If we were to exit the app, we would get an error as there's no geometry in the parent sketch. However, we can add new geometry now. Left-click on the circle icon. Then left-click on the point 2, 2 to define the circle center. And finally, let's left-click on the point 4, 1 to define the radius. To get back to the 3D workspace, left-click on Exit App. And our solid is now a cylinder. We can move back and forth in our design timeline by using the undo and redo commands. To access them, we must left-click on the Standard tab. If we left-click on the black arrow, we can see a sub-toolbar with both the undo command in blue and the redo command in gray. Left-clicking on the background dismisses this sub-toolbar. To demonstrate the undo command, we're going to left-click on the undo icon 8 times to get back to the 1x6 sketch with both vertical constraints. This can be our new design departure point, and we can now modify the sketch as is. Let's change the shape of the rectangle again. Left hold on the corner point at 1.5, 2, and drag it to 1.5, minus 2. Left-clicking on Exit App will reveal our new solid shape. So far, our part has only had one feature. To make a multi-featured part, we must start by making a new sketch on a part face. Let's left-click on the Essentials tab and left-click on the face facing us. We then left-click on the sketch icon, then left-click on the rectangular icon, then left-click on the point -3.5, -1, and finally left-click on the point 0.5, 2. We then left-click on Exit App and left-click on the pad icon. We'll just accept the default 1-inch dimension for the height, and then left-click on the OK button. Our part body now has 2 features. Let's make a new pad feature on top of the last one. Left-click on the face closest to us, left-click on the sketch icon, and then left-click on the rectangle icon. To draw the rectangle, let's left-click on the point -2, 0, then left-click on the point -1, 1. Then we'll left-click on the Exit App icon. We will now make our third feature using the highlighted sketch. Left-click on the pad icon, and we'll accept the current 1-inch value for length and left-click on the OK button. We now have a part body with 3 features in it. We have shown that we have relational design between the parent sketches and the child pads. But we also have it between the sketch and the pad face selected the sketch was constructed on. To demonstrate this, left-click on the plus sign in the spec tree for pad 3. Then right-click on sketch 3. We then left-click on the Hide Show selection to see the sketch for pad 3. Now that the sketch is visible, let's make pad 2 longer and see what happens to pad 3. Double-click on pad 2, left-click in the text box, type in 3, and hit OK. Note that pad 3 was not swallowed up by pad 2. Since the parent face that defined sketch 3 moved up, so did that sketch, which is the starting plane for pad 3, so the features morphed in unison. Now let's save the part to the web. Left-click on the Share arrow. then left-click on Save. The part is now saved on the web as product 0000273. Using a web browser, we can log into our account at 3ds. Using the number 273 for our search criteria, we can see a thumbnail of the part we just made. We hope you have enjoyed the video portion of our simulation training we offer at 3DExtrain.com. Keep in mind that it is difficult to absorb all the material and get fully trained by just passively watching a video. That is why we developed our proprietary simulation training. In this sample of the simulation training, the title in the 3D work area tells us what we are trying to accomplish in the next few frames. Our instruction for this frame is to left-click on the View tab. The mouse icon shows LC for left-click and has the correct button shaded for us. The arrow tip shows the location we are to perform the left-click. If you physically left-click your mouse at the arrow tip in our simulator, you can advance to the next frame. Left-clicking your mouse at the new arrow tip location will advance to the next frame. Right-clicking your mouse at this location will now advance you, and so on. As you can see, you are required to use the correct mouse button at the correct location to advance to the next frame, just like you would in the actual software. Try it out for yourself and download our free test drive software on your PC to see if it is the right training solution for you. We think you will be amazed with the results.